Okay, so here's the last thing that we need to learn in section 5.2, and that is about how do you determine if an inverse is a function from a graph. Okay, so remember that we had the vertical line test that we could tell if something was a function just by looking at it? Okay, that's what we're going to look at right here. Okay, so let's say we have this function, y equals x squared. Okay, I know what that looks like. I know it goes here, and I know it goes here and here. And these points you should have memorized. You should be able to very quickly make that function. Okay. Now, I want to see, well, what does the inverse of that function look like? And we talked a little bit about it yesterday, that the inverse was a reflection over the y equals x line. But let's just go ahead and find the inverse of that function. Okay, so if f of x is y squared, or excuse me, x squared, then that means, oops, that y equals x squared, and x equals y squared. And we know to get from a square, we can take the square root. So I'm going to take the square root of y squared, and then I could put that on there. And remember, if we're ever taking the root, and it's an even root, okay, I could have written to the 1/2. That means the same thing. Okay, so the square root of y squared is y. Okay, plus or minus the square root of x. We haven't really worked with the square root function, so let's just make a t-chart. And I'll just make it right over here. So let's say x was 0, and I plug a 0 in. Well, the square root of 0 is 0. Plus or minus 0, that's 0. How about 1? Well, the square root of 1 is 1, plus or minus 1. So I have two values of y for one value of x. Remember our definition of function said for every x there's only one y? So this is kind of looking suspicious here. Okay, I can't find the square root of 2. I can find the square root of 4. Well, the square root of 4 is 2, so it's plus or minus 2. Okay, this will give me enough to do this. So I'm going to do it in a different color. I'll do it in light blue. Okay, so it's going to go through 0, 0. Okay, when x is 1, y is going to be 1 and negative 1. So 1 and negative 1. When x is 4, 1, 2, 3, 4, y is going to be 2 and negative 2. So all it ends up doing is it's a sideways parabola. Like if I look at it this way, it's just looking like that. Okay, and those would be reflections of each other over the line y equals x. Okay, so is this blue function right here, that's the inverse function, is it a function? Well, hopefully you're remembering the vertical line test. And the vertical line test said if a vertical line goes anywhere through this graph and it touches in more than one spot, then that graph is not a function. So I could say, well, look right here. This, if it touched right here, and it touched right here. Okay, so I'm going to say that this is not a function. And the reason is it fails the vertical line test. Okay. Now, what we want to know is well, could we have figured out, like if I just gave you this right here, and I said, will its inverse be a function? Could we have figured it out without having to do all of this graphing? Because that's kind of where we're headed. Okay, so now I want you to look at, so just keep that in mind right now. And then let's look at one that's very similar but has what we call a domain restriction on it. Okay, so let's say that we have f of x is equal to x squared. So we have that same old parabola, except this time I'm saying that x has to be greater than or equal to 0. So I can't have any negative values in the x's. Okay, so let me put another graph on here. Again, if you have graph paper, I would suggest that for your notes. Okay, so I'm only doing the positive side of this parabola. So it's here, okay. So that's what we say if we have a domain restriction. It's not letting us use any negative values. Okay, so let's go ahead then and look at the inverse of that function. Okay, so that function is y equals x squared, and we're saying that x, so we have to keep our domain restriction on there. Okay, now I'm going to switch. X equals y squared, but I'm going to also switch that. Okay, I'm going to put my y squared equals x over this side. And then I'm going to take the square root of both sides, and when I do that, I have to put in a plus minus. Okay, now I have to take into account this little piece of information right here that says y has to be greater than or equal to 0. So I used that to get rid of the negative. So it's slightly different problem. So again, if I were to graph this, the y values can only be the positive y values, or the top of this graph. So this one would go here, here, 1, 2, 3, 4. So it looks like that. Okay, now in this case, this light blue one, it is a function. It's going to pass the vertical line test. And the reason so, it passes the vertical line test. Okay, so again, our whole goal is going to be, well, we don't want to do all of this work. I don't want to have to graph these every single time in order to tell if the inverse is also a function. So we have something called the horizontal line test. Okay, so let me get a new piece of paper here. So that, and I've got that. Okay, so let's put over here, what is the horizontal line test? Okay, so just like the vertical line test, what it says is that if no horizontal line intersects the graph of a function more than once, then the inverse of f is itself a function. So that's the official definition. And I know it's like, okay, what? What does that mean? Okay, so let's just look at some examples of that. So let's say I want you to determine if the inverse of the given function is also a function. And we're just going to make little sketches here, okay? So let's say that I had like an absolute value graph. So I'm not even going to write it out. I'm just going to look at the graph. So what I do is I check with a horizontal, not a vertical line. So I draw a horizontal line anywhere. Is there anywhere that I can draw a horizontal line that touches in more than one spot? Yeah, it touches here and it touches here. So that tells us it couldn't intersect in more than once. So this is saying, it failed the horizontal line test. It touched in more than one spot. So therefore, three little dots like that means therefore the inverse is not a function. So we don't even have to graph it. We just check. Can it pass the horizontal line test? Okay, let's look at something like that, a cubic function. So I think, is there anywhere I can draw a horizontal line that will touch this function in more than one spot? And I don't include the arrows. So there's nowhere, right? It will only touch, I can say a horizontal line will never touch in more than one spot. And we can say that it passes the horizontal line test. Okay, so if it passes the horizontal line test, the inverse will be a function. Okay, so we still have a lot of work to do with these, so I just want you to know the basics right now. Like if I look at this original one right here, that would have failed the vertical line test, and look at the inverse was not a function. Or excuse me, that would have failed the horizontal line test. If I look at this original one, that original dark blue, that would pass the horizontal line test. And sure enough, its inverse is a function. Okay, so we're going to do a lot more with this, but for right now, I just want you to understand about if the inverse of a function is also a function.